My name is Muhammad Haziq Aidil and Roslan. My numerator is F23A0721. Now I'm going to explain about optimizing feed efficiency in daily cow.
Hello, my name is Joanna Yahya and my metric number is F23A0900. In the video that I will explain is to observe the weight of a cow and determine the time at which the growth rate is maximum.
My name is Noriszatul Binti Musa. My metric number is F23A0328. In this video, I will show you how to determine the time where the rate of disease spread in a flock of cattle is the highest.
Hi, my name is Aiman bin Awang Raman and my metric number is F23A0570. In this video, I will solve one problem of minimizing medication cost for livestock.
The problem statement is a dairy farm in Malaysia want to optimize the feed efficiency for their daily cow. The milk production M for a cow per day is modeled by the function M in bracket X equal negative 0.02x square plus 1.2x plus 15, where x is the amount of feed per day. The cost of the feed per kg is Rm 1.5 and the revenue from selling milk is Rm2 per liter. Determine the amount of feed to maximize the profit. The solution is number 1, profit function. The profit P in bracket X is given by P in bracket X equal revenue minus cost. P in bracket X equal in bracket 2M in bracket X minus in bracket 1.5x. Substitute M in bracket X equal P X equal to in bracket negative 0.02x square plus 1.2x plus 15 in bracket minus 1.5x, and the amount is P in bracket X equal negative 0.04x square plus 2.4x plus 30 minus 1.5x 2.4x plus 30 minus 1.5x. So the equal is negative 0.04x square plus 0.9x plus 30. The next solution is first derivative. Find the first derivative of P in bracket X to locate critical points, which means P in bracket X equal negative 0.088x plus 0.9. Setting the P in bracket X to 0. So negative 0.08x plus 0.9 equal 0. So x equal 0.9 per 0.08. So the answer is x equal 11.25. So the second derivative is check the concavity to confirm a maximum. P in bracket X equal 0. P in bracket X equal negative 0.08 since P in bracket X lower than 0. The function P in bracket X has a maximum at X. equal 11.25. The conclusion is the amount of the feed that maximum profit is 11.25 kg per day. Thank you.
To determine the time at which the growth rate of the cow weight is maximum, we need to find the time that first derivative of W represent the growth rate reach its maximum value. This involves the following step. The first step is find the first derivative to obtain the growth rate as a function of timeline. First derivative is W0.1 minus 0.4 plus 2 plus 0.5, and the second derivative is 0.3 minus 0.8 plus 2. Number 2, second derivative is W0.3 minus 0.8 plus 2. Step number 3 is determine the critical point by setting W equals 0, 0.6 equals 0.8, and the maximum weight is in 1.33 weeks. Analyze the critical point to confirm whether T is equal 4 to 3 weeks is maximum growth rate. We can examine the sign of W around the point. You guys can see it in the slide. Therefore, the time at which the growth rate of the cow weight is maximum is 4 to 3 weeks, mean 1.33 weeks. Thank you.
The third problem, the problem statement is the number of infected cows I in the flock is modeled by logistic function, which is IT equals to 500 over 1 plus 4e to the power of negative 0.3t, where t is the time in days. The question is, determine the time at which the infection rate is the highest. So, from the question, the given function is IT equals to 500 over 1 plus 4e to the power of negative 0.3t. The first step we need to do is find the first derivative of the infection rate. So here, the first derivative is d over dt times 500 over 1 plus 4e to the power of negative 0.3t. And then, we let u equal to 1 plus 4e to the power of negative 0.3t. Because of that, the function will be changed to 500 over u, as well as the first derivative of the infection also changed to I prime t equals to d over dt times 500 over u. Now, we recall that the derivative of function I over u with respect to u is equal to negative 1 over u square. So, the I prime t is equal to 500 times negative 1 over u square times du over dt. Next, find the value of du over dt. So here, we calculate it and get the answer of which is negative 1.2e to the power of negative 0.3t. After that, combine the result using the chain rule. So, I prime t is equal to 500 times 1 plus 4e to the power of negative 0.3t square times negative 1.2e to the power of negative 0.3t. And then we simplify it and get the answer of 600e to the power of negative 0.3t over 1 plus 4e to the power of negative 0.3t square. Second step, find the maximum infection rate. So, to find the maximum of the infection rate, we need to set the second derivative by let v is equal to e over negative 0.3t, and then setting it to 0. So, the second derivative will be d over dv times 600v over 1 plus 4v square. After that, by using the quotient rule, we can get the value of v. So here, the value of v is 1 over 4. So, the value of e to the power of negative 0.3t is also 1/4 because we let V is equal to E to the power of negative 0.3t. Then next we can use logarithm on both sides to find the value of t. So negative 0.3t is equal to negative ln 4, and then calculate it using the calculators, and then we get the answer of t, which is 4.62 days. To conclude this, the time at which the infection rate is the highest is at 4.62 days, or we can say that it is among day 4 to day 5.
The question is, a farm needs to administer medication to its livestock. The cost of the medication C in RM as a function of the number of animals n is given by C bracket n equal to 50 plus 10n plus 0.5 n power of 2. Determine the number of animals that minimize the average cost per animal. For step number 1, we average cost function n bracket a bracket n equal to C bracket n over n. We can get equal to 50 plus 10 n plus 0.5 n power of 2 over n. Next we can simplify to, and we can get a bracket n equal to 50 over n plus 10 plus 0.5 n. For step number 2 is first derivative. To find the first derivative of a bracket n. A first derivative bracket n equal negative 50 over n power of 2 plus 0.5. Next we setting a first derivative bracket n to 0. Negative 50 over n power of 2 plus 0.5, we can get 0. Next 50 over n power of 2 equal to 0.5. The n power of 2 equal to 50 over 0.5, and 0 power of 2 we can get equal to 100. For the n, the last setting of a first derivative bracket n is 10. For second derivative bracket n equal to 100 over n power of 3. At n we can get equal to 10. A second derivative bracket 10 equal to 100 over 1000, and we can get 0.5. Since a second derivative bracket 10 more than 0, so the function of a bracket n as a minimum at n equal to 10. So the number of animals that minimize the average cost per animal is, for the last answer is 10. Thank you.